Hello everyone, this is Lemar Jr. from Zimeco. Welcome. In this video, I'll have the opportunity to talk with Mr. Aaron Stannard, an excellent friend. He's a very operative in his blog. By the way, here is his blog, and this is the address. Also, he is the founder of the PetaBridge. PetaBridge is a technology company which helps .NET developers to develop high performance and distributed systems. Besides of that, Aaron is a top contributor in some open source projects. For example, aka.net project that is a framework for building systems based on actors model. So welcome, Mr. Aaron. How are you?
I'm doing well, thanks. I appreciate you having me on the show. It's been a long time.
Yeah. I'm good as well, and it's a pleasure to have you here. We haven't seen each other in a while. I think the last time was at the QCon. Do you remember that?
2018.
Yeah, 2018.
Yep.
It's crazy.
I gave a talk on distributed tracing. On there, yeah, I do remember that.
That was an amazing talk, by the way.
Thank you. I've been spending a lot of time working on that lately. Actually, we've been doing well, not to get off track here, but was this new standard coming out that's being sort of pushed by Google and Microsoft and a number of other big APM companies like Datadog and New Relic, called Open Telemetry, which is meant to kind of open tracing has been around for a while, which is kind of a standardized vendor neutral way of tracing microservices, essentially being able to go ahead and connect the dots between all of the different services that participated in completing an end user's request. So that standard's been around for a little while, but there was also nothing like that for metrics, which is the ability to go ahead and, use the same terminologies and different metric types for measuring things like application latency, error rate, throughput, all that sort of stuff. And so Open Telemetry kind of combines both of those, and it uses like a single standard library for actually instrumenting your applications, which means that your performance is going to be very consistent when you're using Open Telemetry, whereas Open Tracing's performance could vary a lot depending on how the underlying driver was implemented. In this case, that's all done asynchronously now, so there's no direct relationship between which APM system you're using. APM is short for application performance monitoring. There's no relationship between, like the Jaeger driver isn't implemented as well as the Azure Application Insights driver is, and therefore your app's going to be slower. There's all that reporting all gets done out of band now, and Open Telemetry is very fast. So that should be coming out of beta for .NET developers maybe in the next. Well, just got into beta, actually. It was in an alpha state. So it'll probably be in beta for another 6 months. But then it'll eventually come out. I wrote a prototype of our product that does tracing for Akka.net using Open Telemetry. And the results were our Kubernetes cluster ran out of memory within about 30 seconds. So they've got a little bit of work to do on some of that stuff still. But nonetheless, I've been doing a lot of distributed tracing work for myself and some of our projects that we're working on, as well as some of our customers lately.
Yeah, that's amazing. I've been heard about Open Telemetry for a long time. It's a replacement for Open Tracing, right?
Yes, it's I guess they call so Open Tracing is going to still be around, but it's not going to be developed anymore. And so Open Telemetry is considered to be the successor standard to that. That's going to sort of replace it.
It's the new way to go.
It's the new way to go, but it's still kind of a bit of a work in progress. And the .NET stuff, Microsoft's been essentially driving most of the development around Open Telemetry and .NET. And they were waiting for a whole bunch of stuff to get integrated into the base class library for .NET 5 that they're going to use in Open Telemetry. In particular, it's the system.diagnostics.activity class is going to be the primary driver of sort of all the tracing and correlation stuff going forward. So we'll have to see what that looks like down the road. I think that ultimately we'll probably end up as sort of people who build frameworks like myself. It'll be a lot easier for us to provide a consistent experience for our end users who want to monitor stuff using using something like open telemetry, but the entire industry has to kind of adopt it, meaning people have to start building against the open telemetry APIs and writing exporters and maintaining them. And that's a process that can take several years. So
Yeah,
we'll see
I
how it
know.
goes.
You said that we have a first stable version in something like 6 months. You said that?
I'm just speculating. I said I wrote a blog post on Petabridge's site earlier this year. I think maybe I wrote that. Might have been April or May of this year. It's late August right now. And I said I think we're about a year away from having sort of an RTM'd version of open telemetry. So it's been, I guess, maybe 3 or 4 months since I wrote that article, and now I'm thinking it'll be about 6 months. So I guess I'm kind of splitting the difference.
Yeah.
Yeah.
And you think this first RTM version is safe to go, or should we expect a little bit?
You should always wait until there's a sort of rule of thumb when it comes to adopting a new major version of software is you want to wait for the first 2 emergency patches to be released before you start adopting it, because that's when people find the really horrific bugs that they never found during testing. So you want to go ahead and you might want to wait a little bit.
There are a lot of people that says that you should wait for Microsoft technology, for example, at least 3 versions: version 1, and then version 2, and then version 3, and start using after the version 3. I am not comfortable with this idea, but this is only true for Microsoft. It's not for OpenTelemetry. So expecting a year maybe to start using. Right?
The one upshot of open telemetry is the fact that all the implementations are pretty standardized across different programming languages. So even though the .NET driver might be lagging behind, the TypeScript and the Go drivers might already be in production for like a year by the time the .NET one does. So the .NET developers have a chance to learn a lot about what does and does not work before that goes into production.
Yeah, that's very good. That's very good. Aaron, you have been working on building a profitable business on top of open source projects for a long time. At the Bridge, for example, your company was built on top of Akka.NET project.
Yep.
Am I right?
That's correct.
What are the learned lessons in this field, and what you can share with us?
Man, there's a lot of things that I learned along the way. So Petabridge will be 6 years old in January. So we were founded in January of 2015. Is when we
6 years old, you said?
Yeah, 6 years old.
Okay.
Yeah. So it'll be 6 years old. So the way Petabridge kind of started was a bit of a happy accident. So I had a previous company prior to Petabridge. It was called Marked Up Analytics. It was a large scale sort of SaaS startup for doing app metrics and marketing automation for developers who are building Windows Phone and Windows Store applications. This is all kind of centered around the Windows 8 launch. Now, Windows 8's store was a commercial disaster for everybody involved. No one made any money off of it. One of our customers that Marked Up was Dell, the OEM. And they had a section of the Windows Store they could control, and they were able to go ahead and essentially take some percentage of the profit from apps that were sold on it. Over the course of working with us for about, let's call it nearly 2 years, maybe by this point in time, it was 18 months. They had a team of 3 or 4 people working full time around managing that inventory. Those guys made less than $4,000 from that part of the Windows Store across tens of millions of devices. That's just how big a failure that platform was. Now, that being said, we still had hundreds of millions of data points we collected per day inside our system. And when it came time for us to build our marketing automation application, we needed the ability to do real-time in-memory stream processing, where our customers wanted to be able to specify campaign rules for doing things like for every user who comes inside our application and is inside the United States and looks at buying this in-app purchase, but leaves the page without buying anything, we want to send them a push notification with a discount code to get 25% off. And we want that push notification to hit them within like a second of them leaving that page. So it almost looks like something the developer built into the application. Truth is, this was stuff that we were all computing in real time on our big Amazon Web Services deployment that we were running. This is like 2014 that we're doing this. So we needed a solution for being able to handle all of these abstract campaign criteria for an unlimited number of users, for an unlimited number of apps, potentially. And we made our money based on the number of campaigns and the number of users that we processed. And more accurately, it was really the number of notifications we sent to those users is sort of what we build off of. Now, in order to do that, we had to have a way of doing this sort of highly concurrent, fast, in-memory sort of data processing, where we wanted to represent all the state for one campaign that one user for one app could belong to. And we needed to have this little like finite state machine to figure out whether this user should receive this campaign or not. Actors turned out to be a pitch perfect way of solving that problem at scale. Problem was, this is 2014, there were 0 actor model implementations that were available for .NET other than some abandoned projects from Microsoft Research that had, I don't know, were years old and it just kind of rotted. And then there was one project written by the same guy behind mass transit, one of the big RabbitMQ sort of implementations for .NET. He had a sort of a theoretical concept for actors, but it was never finished, never production ready. So we decided the way to go about this was to take Akka, which was a very successful actor model implementation written in Scala. So it's all on top of the Java virtual machine. And we were going to go ahead and translate that to .NET, get it up and running. And so we started working on that like November 2013. We got it. And by the way, we teamed up with like other people in the community to go ahead and build this. It wasn't just us. And one of the things that came out of that was we had concurrently with building our product on top of Akka.net, because we were the first real production users of it. We had a bunch of people who started adopting it. People from the F# community in particular. It's the functional programming sort of language inside .NET. They started adopting it real heavily. People started writing blog posts on how to do stuff with it. Meanwhile, I'm kind of really focused on my little SaaS company, because I had investors and everything else, and I had employees that I had to try to keep finding a way to pay somehow, even though we're running out of money because our analytics startup isn't making very much cash. So we had about a year of kind of building up Akka.net concurrently with this other business, and then eventually, the Windows Store is just, there's no way to make any money from it. Even though we had a fantastic product that worked really well and was very scalable, thanks to Akka.net and some other technologies we picked, like Cassandra. But thanks to Akka.net and all that, the business still failed. So around like November 2014, so Akka.net's first NuGet package, I think, got released like February 2014. So we had several different iterations by then. Akka.net was still kind of in a beta state around the time my company failed. But we had a lot of users now and people who were looking at using it in their own businesses. And so after I wrote this blog post kind of announcing that I was shutting down my business, I had to lay everybody off, including myself. So I lost my job, and so did all the people who worked for me. I started getting some requests on LinkedIn from people who were interested in using Akka.net to solve some of their own business problems, but they wanted some consulting or some training on how to do it. And so that's kind of where the idea of Petabridge came from. It was a bit of an accident. It was as a result of all this demand for this open source technology that we had really built as kind of an ancillary technology, meaning it wasn't our core business. It was just something that was supporting part of what our business did. So 2 months later, we started a new company called Petabridge. And I think within about, the first thing we did was we got Akka.net out of beta. So that took about maybe 3 or 4 months. I think it was by about April 2015. We got Akka.net 1.0 out there, which and we promised it would be a stable API, it'd be backwards compatible, and it would be versioned kind of like you'd expect from a professional software product. It would have sort of real professional quality assurance behind it, really good documentation. And then we also created the Akka.net Bootcamp as part of that too, which is a free set of lessons for learning how the Akka.net syntax works, how the actor model works, and how you can apply it to your own problems. So the combination of doing those two things, plus a couple of really good podcast appearances, speaking at some conferences like .NET Fringe, right around, like this is all right around the same time. All this stuff happened. Really drove a lot of people to look at Akka.NET all at once. I remember we appeared on .NET Rocks to talk about Akka.NET 1.0 coming out, and we had something like close to 100 people per day signing up to go on our mailing list to go through Akka.NET Bootcamp. And it stayed that way for quite a while. So that really helped us kind of launch our business, but we still had to figure out how to make money. We hadn't solved that problem yet. We had a free product, free training courses, and a lot of people using it, but no one making any money yet. So the first thing that we tried, because it was inexpensive, was for people who had liked our free bootcamp, we started offering these paid online courses, these webinars that I would teach over GoToWebinar. Costs like $500 a seat to attend them, and we'd only let up to 10 people attend each course. That way, the people who are attending can actually get asked questions that are specific to their use case, get answers back, and it becomes unmanageable if you have more than like 10 people in that type of context. And lo and behold, by the way, if we didn't make money the first month we offered these courses, I was going to personally go bankrupt, and I was going to have to go back to work for Microsoft or something else. Thankfully, everything worked out great. We made enough money for me to be able to pay my rent and stay afloat and put food on the table and everything. And it's been we've been growing our business pretty rapidly ever since. So that was really how things got started. Now, in terms of what I've learned over the course of 6 years, is that I'm trying to think. So the biggest lesson I would learn is that when it comes to open source, if you want to build a sustainable business around your open source projects, you have to have a really clear understanding of what it is people would want to buy from you in addition to your open source. Because the open source business model is largely predicated on the fact that it is free for people to use and try your software, because most open source is free. There are some exceptions where there's some open source projects that have a more draconian license that doesn't allow you to use it in production. So like NService Bus and RavenDB, for instance, both use the AGPL, which is an aggressive copyleft license, which isn't safe for companies that want to do things the legal way. It's not safe for them to use it in production without buying a commercial license. So those technologies are all dual licensed. That's kind of the exception. Most open source doesn't really operate that way. A lot more of it operates where you have a license that makes it free for you to use the product. But in order to build a business, you have to sell something else in addition to that. So for us, it was that Akka.NET is a concurrent and distributed programming framework. And therefore, the context in which it's being used is usually to solve a really complicated but critical business problem. Therefore, what people will pay for from Petabridge is they want someone who is confident and knowledgeable to come in and show their team how to use the technology correctly to solve their problem. Because the cost of failure, if you use it in that context incorrectly, is insurmountably high for a lot of these companies. We have some companies using Akka.NET to power business systems that are responsible for generating, $10+ billion a year in revenue. That could be things like real-time cargo networks, where Akka.NET's being used to calculate the real-time position of cargo inside a gigantic shipping system at any given time. And we have to keep track of real-time data from thousands of different shipping containers or individual packages that might be inside them. Kind of depends on the scope you're looking at. We also get used inside things like real-time currency trading systems by large banks, where they're trying to balance the amount of euros and Danish kroner and Norwegian kroner and Swiss francs they have at any given time. We might also be used for things like real-time ACH, automated clearinghouse transactions for clearing payments, that sort of thing. And so that was really kind of our niche initially, was doing all this consulting and training. And we scaled that up until we got to a point where I was able to hire between 2 and 3 sort of full-time people, kind of depending on a couple of different variables there. And The next big problem that I've come across, and this is the one I've probably spent the better part of 2 years working on as a business owner, is scaling that type of business, which is all built around expert advice and training and consulting, is very painful and difficult for 2 reasons. Building that type of expertise where you have an engineer who can be, let's say if I pulled one of my engineers who works on Akka.net all day long. Now they're very talented developers. They know the guts of Akka.net reasonably well. They've solved all sorts of bugs for customers, but most of them have never had to sit down and answer the same sort of questions I do, where let's say you're sitting across the table from a chief technology officer for a big financial startup in London. And they're saying, how can I scale Akka.net to process 30 million transactions per hour for, let's say, processing insurance claims globally? What would my 3-year plan be for doing that? How could I build an architecture that could grow to support that? That is having someone who has that level of expertise in house takes a very long time to develop, and that person has to have had to solve some pretty nasty problems. But on top of that, that person also has to be someone who likes having that conversation, who likes being put in front of customers, likes being challenged, and likes having to come up with solutions on the fly. My experience has been is that there are developers who really do enjoy that type of thing, but they tend to be the exception. Most developers like to sit quietly, work diligently on a complicated problem, and be left more or less alone to do that. So therefore, trying to build a services business around a complicated piece of open source technology requires either spending a lot of time training people, like years training people, and you have to find some way for them to generate income for you while you're training them. So, because if they can't deliver the consulting and the training, they've got to do something else, right? In our case, what my developers on our team do is they spend a lot of time doing research and development on Akka.net. So fixing bugs, adding features, and they also do a great job handling support tickets from our customers. That's all done through writing. That's not quite the same as having like a live conversation with somebody about architecture. That's usually chasing down like a technical problem, either inside their application or inside our framework. But that would be that's actually like a really subtle problem. And it's not something you should worry about when you're first getting started, because the first thing you should worry about is, will anyone pay you for anything? You shouldn't worry about.
That's amazing. That's amazing.
Yeah.
Man, by the way, a lot of things changed since you started the Akka.net project. Today you have new kids on the block. You have Orleans from Microsoft. We have Volvernon with Velingo, I think. There's the actors model project. There are a lot of technologies out there. Probably Akka.net is the more mature option today available. Do you provide consulting and training only for Akka.net on top of Akka.net, or do you provide consulting for adopting Orleans and other frameworks?
We only really do Akka.net. We're probably leaving some money on the table by not consulting on Orleans or Dapper, which is the new one that Microsoft came out with. They also have Coyote, which is another actor framework. They also have Service Fabric actors. So I think Microsoft has released, about on average about one new actor framework per year since we started our business.
Yeah.
So we're probably leaving money on the table by not doing that. But the way I look at it is, well, with Akka.net, we're really the highest authority on the subject because we're the ones who do the work of maintaining it for the most part. But then on top of that, we also have a lot of users who, let's say, aren't really interested in the Orleans approach for doing things because it doesn't scale down very well. So I'll give you an example. We've done a number of IoT projects for our customers, Internet of Things, for your listeners who've never heard of that before. And what most Internet of Things projects looks like for us, usually there's 3 big ones. One Internet of Things is factory automation, where all the things that you're connecting together are sensors and machines that operate around assembly lines, typically. And so these are machines that do things like run conveyor belts. They run pickers, which are the little arms that go and grab things and move them from one area to the other. And they also tend to do a lot of things like image processing, where you have to go ahead and use a camera to figure out how far down the conveyor belt something is. So that's one example of like IoT. Another one, we do a lot of IoT projects in the energy industry. So these include oil fields. These include energy producers. So like one of our biggest users in Europe is Schneider Electric. And they process a lot of things like power meter data coming from homes in order to do billing and metering, that type of thing. And then we also do some IoT projects for the transportation industry, where someone will do something like rig up a train with a ton of sensors for being able to analyze the quality of the track underneath it as it's going. It's for safety studies and that type of thing. Or they'll go ahead and do fleet and vehicle tracking. In a lot of these cases, particularly when you're building something like a set of highly concurrent software that has to be deployed on location, like it has to be deployed to an oil field, it has to be deployed inside a factory, it has to be deployed on a vehicle. Something like Orleans, which is really designed to run in the cloud, ditto with Dapper and some of these other frameworks, just can't really operate in that environment because Orleans really needs to bring all this other infrastructure with it that you don't necessarily need or want inside a factory floor. On top of that, there's differences in the way the actor model is implemented between Akka.net and Orleans. Good example. Akka.net's average throughput is going to be a lot higher than Orleans is because Orleans' concern is largely abstracting away the potential weaknesses of the network away from its end users. You don't necessarily want to be in a position where you have to worry about messages getting lost over the network. These are all things that Orleans does. You might want to make sure all your actor state is automatically persisted to some backing store somewhere. You want to make sure that you do a deep serialized copy of every single message in order to make sure they're immutable. And Orleans does all of that out of the box. And that's designed to provide safety. Akka.net, on the other hand, will do those things, but only if you explicitly tell it to. By default, Akka.net is designed to be very fast. And that means doing fewer things out of the box, meaning fewer moving parts, right? So as a result of that, there's applications that we've had to build for some of our customers, or we built with them, where they had originally done a proof of concept on Orleans, and they could never even get remotely close to what their benchmarks required. If they're required to process this number of events per minute, and they can't scale up to it because of the way the virtual actor model works, you're going to have to look at something like Akka.net in order to do that. And moreover, though, in terms of, let's say, the competition for users inside the open source ecosystem, and really just say the .NET ecosystem as a whole, I don't think it's a bad thing that there's multiple options out there. Now, obviously, Microsoft has a big advantage in the .NET ecosystem, given that they have this kind of singular influence over what people do and think on the platform, and they have a group of super fans who are going to think everything they do is wonderful, right? That's just kind of a reality of competing with Microsoft within their own ecosystem, that is. That being said, it's still a good thing that there's alternatives out there because there's things that we can learn from and improve on as well as them, right? And I also think it's good for developers to have choices inside an ecosystem. If we had a monoculture inside .NET where there was only one true way of doing things, which by the way, we still do kind of have a monoculture in a couple areas. But that being said, if there was only one true way of doing things, then the .NET ecosystem will go back to where it was in 2012, 13, 14, before .NET Core came out, which is frankly an ecosystem that's not very creative, that doesn't have the right tools for solving a lot of problems. And basically the only thing holding it together is inertia. The fact that there's so much stuff already been built on it, and it's too expensive to migrate it to a more innovative ecosystem like Node.js or Java, right? So I think that it's a good thing that we preserve some vendor diversity inside the ecosystem. And that includes having multiple frameworks from a giant vendor like Microsoft, but also having frameworks from independent vendors like Petabridge.
That's great. You have been talking a lot about open source, the open source environment in the Microsoft and .NET ecosystem. You have been talking about some actions from Microsoft that makes the life of open source developers like you not so easy.
No.
So, would you like to talk about it?
Yeah. So I've been there's been a lot of debate in the .NET ecosystem. Just to set the context for everybody, there's been debate going on for 2 or 3 years now about just within the .NET ecosystem about the role of the .NET Foundation, which has been around for 4 or 5 years now, about the role of the .NET Foundation, Microsoft's relationship with it, and an even bigger picture, Microsoft and really .NET's relationship with its own open source ecosystem. So here's the problem, as I see it. And Microsoft has more or less admitted, I've got Twitter conversations with David Fowler and other people sort of high up inside the .NET organization, where they basically have come out and admitted that their strategy for how they build the ecosystem is NIH, not invented here. If it's not a first-party Microsoft offering, it's not trustworthy and can't be brought into the core framework, and Microsoft has to have a hand on the steering wheel in order for those things to change. If Microsoft doesn't have that hand on the steering wheel, then they're going to have to invent their own copy of that same idea that originated in the open source ecosystem. So Microsoft routinely strip mines its own open source ecosystem for creativity, and it kills off a lot of potential, let's say, potential homes for, let's say, third-party frameworks and different ideas and concepts about how to go about doing things inside the ecosystem. So a good example, when Microsoft created their own dependency injection framework as part of .NET, they killed off one of the areas of their ecosystem that had a lot of diversity and a lot of choices, which was third-party DI systems. So projects like Inject and AutoFac and a lot of others all of a sudden had this competition coming directly from Microsoft, and projects like Inject eventually got abandoned, even though they had been maintained for 6 or 7 years prior to this, which is a long time for an open source project. So this sort of habitual strip mining of their own ecosystem, and by the way, that's not driven by some evil sort of capitalist stuff going on inside Microsoft. That's driven by their product management strategy, which comes from a good place. Microsoft wants to provide a consistent, high quality, reliable, backwards compatible experience for all their users. If they recommend something, they want users to go ahead and trust them that it stands behind Microsoft's track record of being backwards compatible, of being well maintained, well documented. And that's one of the reasons why people are so quick to adopt things that Microsoft recommends in the .NET ecosystem, is that even if it's not the best solution, it's going to be well maintained and reliable. They're not going to have to worry about some fly-by-night vendor dying overnight, right?
Yeah, that's a problem because Microsoft is so big, but so big that in the enterprise environment, it's common to see people saying that, okay, we can trust in Microsoft because Microsoft's a big company, a very stable company, and why should we put our lives in the hands of some
Random
open?
person.
Yeah. It's easier to trust in Microsoft, and I believe as well that Microsoft don't want to be evil, but it's almost impossible to compete with Microsoft. At least if you don't have a very good option like Aka.net, for example. It's hard.
As Paul Stovall put it, he's one of the founders of Octopus Deploy. The way he put it was, in order to compete with Microsoft, your product has to be like 10 times better than theirs. You can't be twice as good. You have to be 10 times as good in order to overcome that sort of bias the ecosystem has around it.
A good example, for example, is Entity Framework. Entity framework is not the dream framework to the dream or ORM solution. We have another solutions in the market, in the marketplace, but actually there are a lot of people that start using Entity framework not because it's good, but because it comes from Microsoft. So this 10 times better is, and it's not an easy thing to have because they have resources, they have money, they have very talented people. You, for example, you have to write code for Arc.net, and for sure you have the help of the community, but you need to provide consulting and training and train your own people, and that takes a lot of time.
Yeah,
And
I don't have a $100 billion Microsoft Office plus cloud business unit financing the development of Akka.net. So that certainly makes it a lot harder to compete, because in addition to, as you point out, in addition to running an open source project, I also have to run a business, and doing just one of those is a lot of work. Doing both all the time is a balancing act that somehow I've managed. Although I've somehow managed to do over the course of 6 years here. But I would say this in terms of, so some of the things I've raised in the .NET ecosystem to kind of help frame the problem in terms of why should you care? Why should you care about third-party vendors giving up and not wanting to participate in the ecosystem anymore? Well, the answer is, like I said earlier, we're going to go back to 2012, 2013, 2014, where the .NET ecosystem was compared to others very underdeveloped. I wrote a blog post called "The Profound Weakness of .NET Open Source," where I ran down a list of all the things that, as a CTO of a 3-person startup, all the technologies I had to invent to build my product on top of .NET. I had to invent a socket library. I had to invent an actor framework. I had to go ahead and invent a bunch of data structures for doing combinatorics and things like that. And all these things that you would expect would already be out there, like a healthy, mature ecosystem that's been around for 20 years. But Microsoft has this way of just retarding the entire ecosystem as a result of essentially ham-fistedly trying to micromanage it. Whenever a big enough customer needs something, they want to introduce into the framework. And then Microsoft's own track record with abandoning their own technologies isn't very good, by the way. They invent as many technologies as they forget at any given year,
Silverlight.
Silverlight. Gosh, I put together a presentation that I gave for the Los Angeles .NET meetup group in I think it was August 3rd, I think is when I gave this talk. And I came up with a list of just things I cherry picked of like big repos of technologies Microsoft had invented. And some of these repos had several thousand stars on it, where these were like toolkits for doing AI and things like that inside Visual Studio, where they haven't been updated in like 3 years, And it's just crazy to me that people can't really see the big picture in terms of what the problem is. If you chase out third-party innovation from your ecosystem, the problem is that Microsoft, even as big as it is and as many software developers as it has, it can't compete with the entire world in terms of innovation. That's how we ended up in a place in 2014, 2015, where you got made fun of for trying to run .NET in a cloud environment, because AWS kind of supported it. And I can speak from experience. I ran a very high traffic system on AWS for years, 2012, 13, 14. But like AWS only barely kind of supported it. Azure sucked, for lack of a better word. And we didn't have great tools like Chef or Ansible that really supported Windows properly. They kind of do now, but even today, it's kind of a very half-assed sort of experience compared to what it's like on Linux. And all of this was due in part to Microsoft essentially curbing down on some of the innovation coming from the open source ecosystem by simply ignoring most of it for years and years. And now what do we have? We have a Linux subsystem inside Windows, because developing software would be impossible on Windows without it, essentially. We have Microsoft rewriting chunks of their flagship development product, Visual Studio, on top of the Atom editor, so that way they don't lose customers to ReSharper and other sort of technology vendors. Most of the workload on Windows Azure is all Linux systems. It's mostly Linux running on Azure these days. And then on top of that, we had to make .NET Framework cross-platform with .NET Core. And these were all things they had to do as a market response to how badly Microsoft's sort of vision of software development was beaten in the marketplace. Now, fostering a healthy open source ecosystem is a strategic advantage for any platform vendor, whether you're Oracle building Java or Microsoft building .NET. You want to have a vibrant and healthy ecosystem because you cannot possibly solve every software engineering problem anyone might have in your ecosystem. You need to rely on some third-party vendors who are going to come up with niche or sort of horizontal solutions for some of those. So a good example, ImageMagick in .NET. Microsoft does not want to get into the business of writing super detailed image processing libraries, even though I'm sure they have a lot of applications for it inside something like Azure ML or something like that. You don't want to be in the business of doing that because you run into a lot of weird edge cases. It's very esoteric and it's expensive to maintain. Having the people from Six Labors, the company that's trying to monetize their work around ImageMagick and .NET, having that company be profitable and do all that maintenance work is an in-kind contribution to the health of Microsoft's business in the .NET ecosystem. You want those vendors to be healthy. On top of that, as a .NET consumer, you want those vendors to be healthy too, because it means that someone is going to care about fixing the bugs that you report, adding the features that you want, and updating the documentation and the examples. Without that, if everyone becomes reliant on Microsoft to build everything, the entire ecosystem will eventually stagnate, where there's going to be so much stuff going on and Microsoft can only focus its attention on so many things at once. Some things are going to eventually start getting ignored. Really, you need a big group of technologists all working on behalf of the end users because there's commercial relationships afoot there in order to build a healthy ecosystem. And the worry about Microsoft is that if you build a popular technology that starts making some money, Microsoft's going to come along and find a way to take that chunk of business from you. And that's why they keep cannibalizing their own ecosystem. So eventually someone like me, if let's say I finally had enough, I realized that there was no way I was ever going to make a profitable business, the way I want to on Akka.net. If I finally woke up one day and decided I just had it, what would I do? I don't know. I'd probably shift my focus into building software as a service or something like that. And I wouldn't be so involved in building and maintaining these open source tools for people. And that would be just yet another piece of technology that had a lot of promise that just goes abandoned inside the ecosystem. And Microsoft does contribute to that in both directly and indirectly through the way they interact with their ecosystem. Now, what are the solutions to that? What are the solutions to solving this problem?
Yeah, it's a hard problem to solve because we have, for example, the JSON library, the Newtonsoft JSON libraries. It was very popular, and now Microsoft started using this in .NET, and then started replacing this after getting the author as an employee. And you, for example, was a former employee at Microsoft as well. So who knows if in the future we will have Mr. Aaron Stannard as a Microsoft engineer talking about Akka.net inside the .NET official.
Akka.net as an Azure service.
Yeah. just kidding. But it's not impossible. Changing the subject a little bit. We have another options for actors model outside Microsoft environment. We have, for example, Elixir now making Erlang more and more popular as well. By the way, Erlang's getting more and more used all these years. How do you see the competition? Because I think that people who starts a project with the actors model don't care that much about switching technology and that start using another framework. If I need to start a project using aka.net and C Sharp, maybe or F Sharp, I can switch to Elixir with Erlang or aka in Java. How do you see this kind of competition?
Well, in terms of competing with other platforms, I suppose here's how I look at it. People choose .NET, and but largely aka.net gets chosen because .NET was already chosen as the platform for that company. It's not necessarily because people aren't going to necessarily walk off the street and say, well, if I have a greenfield project and I can hire any developer I want, am I going to go, if I know I need to use the actor model, am I going to pick something on a common virtual machine language like the CLR or the JVM, or am I going to pick something like Erlang, which was the OG actor model implementation? If I were in that person's shoes and I was already familiar with the concepts of the actor model, knew how to do design with it and everything, unless I had some outstanding reason for still picking .NET, let's say there was a really complex image processing library I needed to depend on, and I needed my actors to use inside the application, like Matrox, for instance, I might still pick aka.net in that case. But otherwise, with that exception set aside, I'd probably go ahead and pick Elixir for doing that. Because, hey, the virtual machine is custom tailored to go ahead and support that type of performance. It's got years and years and years of support. And on top of that, it'd be fun. I'd go ahead and have a chance to learn something totally new. I say that as someone who's been programming, .NET for, I guess, since 2005. So yeah, about 15 years. So that would probably, the way I kind of look at that is like our ecosystem that we are trying to fish for users from is overwhelmingly people who are in .NET for extenuating circumstances, meaning that like they're working for a giant bank and .NET is the approved platform for that product, right? So they're stuck on it, but they still need some solution for handling their concurrent and distributed programming needs, and aka.net can be a great fit for that. So, yeah.
That's perfect. José Valim was the creator of Elixir, and José Valim is a Brazilian guy. Did you have the chance to meet José Valim?
I don't know. I don't know if he was at any of the QCons that I attended. He might have been, but I can't recall off the top of my head.
Probably yes, because it's a curious fact, Elixir was born in Brazil by a Brazilian, created by a Brazilian.
Well, goes to show you, like, good ideas in the open source ecosystem can come from anywhere,
Yeah. That's incredible, man. If I had a time machine, what technology would you invest time learning today that you neglected in the original path? What would you learn if you could come back to the past?
If I could come back to the past, what would I learn? Well, if I hadn't followed the path that I did follow, what I probably should have done if I wanted to make a whole bunch of money, like all in one go, I should have been learning iOS, and Objective-C right as the App Store was launching in 2011. Was it 2011? No, it was earlier than that. It was like 2009. It came out. It was the iPhone 3G when that came out, which is like the second release of the iPhone. That's when the App Store came out. That's when they had Exchange support and 3G connectivity. That basically solved all the big objections people had with the first model. I probably would have learned iOS and released a bunch of, fart soundboard applications and made $1 million in the span of like 3 days. I would have done that. But I'm actually not kidding when I say that. I probably would have done that. However, thinking more big picture, if I had a time machine, there's something else I could have really spent some time learning. I probably would have spent some time. Now, I'm going to separate my business side from my geek and engineering side. On the geek and engineering side, Unity 3D. I would have learned how to build some video games. That would be what I would have done.
I don't know if you know, but I spent almost all my career writing computer graphics, the software, with OpenGL and DirectX. I don't know if it had the
You think you
opportunity.
told me about the DirectX?
Maybe some 5 years ago, I told you this history. But yeah, I never had time to start learning Unit 3D, for example. I spent all my life with OpenGL and DirectX, but never with Unit 3D. But would you like to learn Unit 3D to create games and to start a game business?
I think the game business is so we've got some customers who build video games. So Aka.net gets used pretty often for building multiplayer games. It's one of the things it gets used for. It's really easy to control NPCs using the little actors and things like that. Man, I probably would have. Starting a video game studio is very high risk compared to building like business to business software because it's a winner take all market and it's very expensive to build a video game. Building a web application is much cheaper by comparison. So I don't think learning Unity 3D would be a great idea from a business standpoint because of how much risk is involved. But from a personal sort of creative standpoint, I would enjoy it. From a business standpoint, if there's a technology I could go back in the time machine and learn, probably would be doing some pretty serious natural language processing would be the one that I would do. Learning how to do, let's say, a single shot text generation, like that GPT-3 algorithm that just came out, that
Well,
people have been, that's just been blowing up all over the internet the past couple months.
yeah. That was the first time I started figuring out what should I do because I know that the GPT-3 can't write software as people are talking about, but it's still impressive,
It's still impressive. Absolutely.
impressive. Um, What would be your advice for those who want to learn how to write better code, man? You have been writing code for a long, long time. What would be your advice for people who wants to be a better developer?
Um, so there was a quote that my English teacher taught me when I was a junior in high school. And what he said was those who want to become great writers must read a lot. That basically the way you learn how to become a great writer isn't through writing all the time. It's through reading how other people tell stories and how they make interesting characters or how they introduce twists into the plot and that sort of thing. I think the same is true for writing great software. That one of the best superpowers you can have as a software developer is being able to read a code base that you had never had any part of, being able to figure out what was the programmer's intent. How is this, how is this function called and what is it used for? And what are the other sort of extensibility points for it? Because what this will help you do is it'll help you start identifying patterns for how to manage things really well. So a good example, I've obviously studied the original Scala code base for Akka quite heavily. And the original developers who put that together were just brilliant in terms of the way they were able to model all sorts of complex and concurrent stuff down into these reusable and fairly sort of like logically separate little components that could all still work together. And so I really got a chance to appreciate how I could go about building, let's say, more robust designs. So I'm looking at what they did in a lot of respects. And then since then, I've also done things like we were talking about open telemetry at the beginning of this call. I looked through the open telemetry code base in a lot of detail when I was working on building a proof of concept for one of our products on top of it. And I really got a chance to say, like, wow, they really organized this in a very in most of the areas. They organized this in a very elegant way, and I could really appreciate from a performance point of view why these things are written. And having written telemetry systems before where I'm measuring, counters and all this sort of stuff, I could see how they did it differently than I did. And I was like, that's why that's a better design than what I came up with. Oh, that's how they handled this problem that I ran into at large scale. And it's, learning how to write great software is something that you'll never master. There's always going to be lessons to be learned that are always going to be out there. But one of the things you can do immediately to start getting better is to learn from the other people around you. And the best way to do that is by learning how to read their source code and to understand the intent behind it. And that's one of the biggest benefits of open source that people overlook is when you want to ask, why does this thing work this way? The answer is right there inside the code base, but so few ever go and look at it, you know?
That's incredible, you know, because I think 2 months ago, I did this very same question for Aranini Ainde from RavenDB, and he provided the very same answer. Start reading a lot of code, because then you can learn about patterns and understand the way people solve complex problems. That's amazing. That's about the hard skills. And talking about soft skills, because besides of being a programmer, you're a developer who share your code in the internet, and it receives, I think, a lot of feedback, some good feedback, some not so good feedbacks, some good pull requests, some not so good pull requests. What about the soft skills? What do you recommend in this field?
Well, I'll give two pieces of advice on the soft skills. First, if you're going to go into open source, or if you're going to start your own business, you have to have a thick skin, meaning you can't let someone criticizing you or someone saying something you don't like. You just can't let it affect you. You'll go crazy otherwise. When a customer or user tells me, hey, ended up deciding not to use Akka.net, or we decided to go with Orleans, something like that, you know, it bothers me, but only to the extent that it should, in order for me to learn the right lesson to make our stuff better. And so you should look at this as an opportunity to understand your users and customers better. And that can only come from a place where you don't take that person's decision personally. You look at it as data that indicates that either your the competing technology is doing something that appeals to that person better, or they're actually really doing something better than you. If someone came and told me, hey, the performance of this area of Akka.net sucks, we're not going to use it, I can take that information and I can turn it in. I can act on that information. I can tell one of the engineers on my team, or I can do it myself and say, here, we need to come up with a benchmark for this area, and we need to figure out how we can get that benchmark from whatever its current value is to some acceptable value up here. And we got to do that without breaking the APIs inside our system. So that's one. I'd say the second thing from a soft skills standpoint is, I guess this is kind of a corollary to having a thick skin, is always assume that when someone is speaking to you, they're coming from a place of good intentions more often than not. That when someone criticizes you or what you said or your code, they're not trying to pick on you. They're maybe expressing it in a way that doesn't come across as helpful when it comes up, or maybe they're upset. Maybe they've had a bad day. Maybe they've been wrestling with this bug that was, basically caused as a result of some issue that wasn't fixed inside your open source, and they're acting out on it. I think everything from, let's say friendships to marriages to businesses to open source projects all runs a lot more smoothly when we give people the benefit of the doubt out of the gate. And so, I think those two sort of soft skills lessons have been things that I've really taken to heart over the years. And it's definitely made me a lot more effective everywhere across the board. So, yeah.
Fantastic. No words to talk about this, because that was an amazing piece of advice, man. Thank you very much. In all this time talking with people smarter than me, a lot smarter than me, like human, the best answers I got are for questions that I didn't make. What should I have asked you but I didn't? And what would be your answer?
All right, since we've covered a lot of subjects. Here's the question you should ask me. When should you start your own business? And my answer to that question is that, as you know, because you have started your own business, my answer to that question is you should start your own business when you're willing to risk every dollar you put into it and never see it again. So you should basically look at all of it as potentially a lost investment. But the primary goal behind your business should be to realize a vision of work that you have that is not achievable working for someone else. And also to have, it's essentially like the number one reason I went into business for myself is I wanted full creative control over what I spent my day doing. That is very important to me. That's a central part of who I am as a person. And I was working for Microsoft prior to starting my first company. They're a fantastic business. They paid really well. I had great benefits. I worked with really good people. But you know what? I had to get lots of different managers and lawyers and PR people to give me permission to do anything. Microsoft's a much more permissive place now than it was then, but it's still a place where I have to spend a lot of time and effort getting buy-in from people who aren't actually going to do anything. Whereas if I feel like, shipping a new version of one of our open source projects tomorrow, I can just make that happen if I want. And there's a lot of costs that come with running a business. The biggest one is probably the uncertainty. You don't know where your next paycheck is going to come from. If you're the owner, you have to be responsible for bringing in all of the business and all the money, and making sure, by the way, after you do a deal with the customer, you still got to make sure they pay you, which isn't always a sure thing. And there's a fair amount of stress in that. But if you're willing to tolerate that uncertainty in exchange for being able to have creativity and the freedom to express it without having to ask anybody else for permission, then you should do it.
Fantastic, man. I totally agree with you because, as you said, I just started my business maybe 3 years ago, and I've been doing my best as a providing consulting services here in Brazil and in some countries, and that's entirely true because starting a business when you know that you will have the opportunity to make things in your own way, and that can make the difference. This is that's the only way to go when you have something like this to do. Fantastic. I totally agree with you, man.
Good.
Aaron, it was such a pleasure to talk with you, my friend. The bad thing about all this coronavirus thing is that we can't travel anymore.
Yep.
Last year, I spent almost all my time traveling. I know that it was the same for you. And this year, we are not allowed to travel as we usually did. But we have the opportunity to talk with people we respect, like me now talking with you. It was really a pleasure. Thank you so much again for accepting our invitation. I expect this is just the first opportunity to talk. Let's talk again in the future.
Absolutely. And congratulations on all your success. And I really appreciate you having me on. It was good to have a chance to shoot the breeze for a little bit.
Fantastic. Thank you very much.
All right.
I need to invite people who is not subscribed in your channel to subscribe it. I am a programmer, developer, consultant, provide consultants, and now I'm a YouTuber. So I need to invite people to subscribe the channel. So if you didn't subscribe the channel, please do it right now and activate notifications. Thank you very much. Bye.